Hi, in this video, I will explain interpreting summation notation. Let's start with summation notation. The summation notation is actually sigma notation, and we'll use sigma notation to explain, to show addition of numbers. For example, I have a summation here, 1 plus 2 plus 3 plus 4 plus until 10. Okay, I can show this summation using sigma notation. Sigma means addition or summation. I need to use an index number. Index is E and I will start with 1. The last value is 10, so this will be 10. And I would like to add numbers 1, 2, 3, 4 and until 10. So I have to write here I, because if I is 1, then I will write here 1. If I is 2, it will be 1 plus 2. If I is 3, 1 plus 2 plus 3, and I will get at the end an addition of 1 to 10. Other example, 1 square, 2 square, 3 square, 4 square until 8 square. Again, use the sigma notation. Let's say the index is k now. Index is k until 8, and I have to write here k square. Okay, now I would like to explain a relationship between summation notation and definite integral. So start with write Riemann sum. Okay, I would like to show write Riemann sum using an example graph. X and Y axis. This is f of x. And I would like to calculate area between A and B. And this graph is parabolic and we don't know the exact equation of f of x, so we can't calculate the exact value now, but we can calculate the approximation using write Riemann sum. F of x from A to B approximately equal to a write Riemann sum. To write the values of write Riemann sum, I would like to give some unknowns for A and B. If I say A is x0, the initial x value, and I would like to show the rectangles, right rectangles here. I will show values from right hand side. And the first one starting from x1. So I will draw here n rectangles. If I draw n rectangles and if I say A is x0, then B must be xn. And to write the area of rectangles, I need base of the rectangle and height of the rectangle. The first height of the rectangle will be, this is x1, so f of x1. And the last height will be f of xn, because write Riemann sum depends on right x values. The first x value will be x1. So we have to calculate the base now. I have n rectangles and I divided b minus a into n pieces. So delta x is here, base of the rectangle. Delta x is b minus a over n. This is important. Now we can write the values of write Riemann sum. Okay, first rectangle will be f of x1 times delta x. The second rectangle's area will be f of x2 times delta x, till f of xn times delta x. Nice. Now I would like to write all values, all x values in terms of x0. To write in terms of x0, I need to think about how can I write x1 in terms of x0. x0 plus delta x will give me x1 because a difference between x1 and x0 is delta x. So I wrote here x0 plus delta x. To write x2, this time I have to add 2 delta x because until x2 I will add 2 delta x to f of x0. And the last one will be x0 plus n delta x times delta x. I have delta x here. Okay. Then I would like to write a generalization for right hand side. Every time I add delta x times f of x something. To generalize, I will use sigma notation because this is a summation. So I will use sigma notation. And my index will be e, and the first number will be 1. And I would like to use index for the coefficient of delta x because I have delta x here, but in the second term I have 2 delta x, and the last one I have n delta x. So I represent the coefficient of delta x. The last value will be n because the last value is n times delta x. So inside I will write f x0 plus I delta x times delta x because I have a multiplication of delta x. Okay, this is approximately equal f of x dx, but I would like to get exact equality. To get exact equality, I need infinitely many rectangles, and to get infinitely many rectangles, I need limit. If limit n goes to infinity, the sigma notation from 1 to n, f of x0 plus I times delta x times delta x exactly equal the definite integral from a to b f of x dx. We got the formula now. This is our formula. Thank you for listening. This is the end of the video.